Now that we know how to use 2D sketches to create 3D parts using the extruded base and the extruded cut tools, and we've also created a sheet format to provide a border and title block information, we're ready to move on to create a 2D drawing. As I've mentioned previously, drawings are a way to represent in 2 dimensions the part that we've created in 3 dimensions. While a lot of manufacturing is moving towards manufacturing straight from a 3D model, it's still helpful to have a set of 2D drawings that you can recreate the part from, if you need to, from records, or some shops still may be working from 2 dimensions. In fact, in reality, probably, the majority of manufacturing still creates parts from 2-dimensional representations of their 3-dimensional shape. So let's go ahead and start creating a drawing representing one of our parts. I'll go ahead and open up a part that I've already modeled. Okay, and you can see this is a pretty basic bracket, a simple 3D shape that I want to create some drawings from. And there's a couple different ways I can do that. I can either go up to New, just click on New, and it would bring me to a window where I can create a new drawing. And as we talked about previously, when we're working with drawings, it'll ask me if I want to use a sheet format. And I've created a sheet format, so I could go down to John Sheet Format and select that, and you can see it brings in the border I've defined previously and my title block. So that's one way. But if we already have the part open, so I'm going to close that. If we already have the part we want to make a drawing of open, there's an even faster way, is to go to New and say Make Drawing from Part Assembly. And that way it knows that I'm trying to make a drawing of that specific part. Again, it asks me, do I want to use a border? And I can say yes. And I'm going to do this one more time, showing you one other tool I can do differently there, the difference between the Novice and the Advanced tab. So again, if I go back to New and Make Drawing from Part Assembly, oops, that skipped it, sorry. I want to do it from just going straight to New. If instead of using the Novice format like this, if I have it in Advanced, you can see I can skip straight to the template that I want without that intermediate step. So I can just say John A size, and it brings in my drawing here. So now I have a blank drawing with my border, and I need to add some views to it. I can do that by coming up here to Drawing, and if I want to bring in just one specific view, I can go to Model View, and it says what model do you want, and if you have the part or assembly open already that you want to create the drawing from, it lists that here. And if you didn't have it open, I could get to it by just clicking on Browse and select whatever part that I want. But I do already have it open, so it's this one right here. So I can double click on that, and it says what view do I want to add, and I can click on I could click on just my front view, and these panes here over on the side, it helps to think of them as basically a glass box around your part. So when I look at this one in the middle, that would be looking at the front of my part. So if I come back to my part file, and if I click on my front view in my view manager, or you can do it from heads up display here, if I click on the front, that is going to be the view that's the front of my drawing. The top would be, again, this glass box, think of it looking at the top. And I can do the same over here. So front, and look at my front, look at the top, look at the right, and that gives you an idea of what the views will look like in the drawing as well. So if I come back over to my drawing, I can select which view I want to bring. So if I click on front and drag that over, you can see it will bring in a front view. Going back, let's delete that and just look at it again. That is if I want to bring them in one at a time. I can also have the option, you'll notice, to say create multiple views. I could say I want to create a front, a top, and a right, and every one that I click, and I could do an isometric, it's going to bring in all at once then. Okay, so there's some views. And this is a good time now to talk about how those views are oriented and the difference between third angle and first angle projection. So in the US, the standard is third angle projection, and in the Europe, the standard is typically first angle projection. And you can change that by going to your sheet, right-clicking and saying Properties. And this brings up the sheet scale. So if we want to, let's show what happens if we change that. Let's say we want it 1:1 instead of 1:2, and I applied changes. You can see all of my views got a lot bigger. Too big, right? They're overlapping each other. They don't fit on the page. So I can go back to Sheet, go to Properties, and change my sheet scale back to 1:2 like it had suggested. Apply those changes. That makes them more reasonable size. But now let's take a look at the projection like I was talking about. So again, we want third angle projection. That's what we use here in the US. Let's change the first angle just so you can see the difference. So before I do that, actually, let's go back and look at this. In third angle projection, what we're going to be using in this class, you can see you have the front view right down here in the corner, and then you can look at it as if you rolled the part so that you were looking at the top. If you think about if you were looking down on this front view from up here, that would give you this view here looking down on the top. And same coming from this side. If we're looking at the front view and think about what would it look like if we were standing over here looking towards the front view, we would see this right side face, this face right here. So this is third angle projection, what we want to be using. Just for reference, let's go ahead and change it to show you what first angle looks like. And you can see it switched to what in my mind looks wrong now because I'm so used to third angle projection, and I think it does make less sense in general. So our front view is still the same, but now you'll see that instead of being a top view up here, what it is a bottom view. So this view is as if you were looking at this part here from down below, even though the view is located up above. So to get what we would consider a top view in this first angle projection, I need to get a view down below. And you can always do that. You can always add a view by saying projected view and then just dragging in the direction you want. So if I click projected view and then bring it down, you can see that gives me a view of what I think of as the top, but it's located at the bottom of the front view. So we don't like first angle projection, so let's change that back to third angle so things make sense. Okay. So that's an overview of creating views. Let's look at that a couple different ways we can do that. So I did it that time by going up to model view. You'll see you can also just click standard 3 view, and it automatically then brings in our front, right, and top views. You can see this time it brought them in at a different scale than before. So if I right click on or just click on this view itself and come down here, you'll see that it's using the sheet scale and says the sheet scale is 1:4. So let's go back and edit our sheet properties, and instead of 1:4, let's take that maybe 1:3. And that's still pretty small, but we'll leave it. We'll go to 1:2 for now and see. We might have to make it smaller again later if our dimensions start overlapping each other. Okay, so we've got a 3-dimensional view. Let's say I wanted to add in that isometric or 3D view. Again, just as a reminder, anytime you want to add a view, just click on an existing view and it brings up this context sensitive window that says a couple different things. Open the part that the drawing is based on, open the part in position, but that's not what we want to do. That would let you edit it actually in the drawing here. But then that third one is create a projected view. So if I click on that and then just drag any direction, you can see if I drag to the left, I'll get a left view. If I drag down, I'll get a bottom view. But I want that 3D view, so I kind of drag up and at an angle, and it creates a 3-dimensional view. So now that view is a little closer than I want to these other ones, so I'm going to move my front view down a little, move my right view over so it's not overlapping my title block, and then I'll grab and move my isometric view kind of up into the corner here. Okay, so that's an overview of our views. We can change the style of the view. You'll see that these are what's called just visible edges. We can't see anything if we couldn't see it in real life. So if you're looking like at this front view here, we know by looking at the part over here that there's a hole bored all the way through there, but you can't tell that from this view. You can change that by saying what type of view it is. Instead of visible edges, if I click over here, you can see I can do hidden lines visible, and now all of a sudden it shows me as dashed lines all the different lines that make up the part, but shows me ones I can see are in solid lines and ones that I can't see are in dashed lines. That can be helpful if I didn't, let's say for example, I didn't have this isometric view in here. When I have my views, let's go back and set them back to be just visible edges. When it's like this, there's no way that I could tell how deep these counterbore pockets are. If we go ahead and add back in that isometric view, that'll help us remember that those are counterbores, or little pockets to hold the head of the bolt or fastener there. Without having something that I can dimension on here, it would be really hard to tell how deep those are. So if I switch the view to show hidden lines in there as well, now I could add a dimension in here that shows how deep those are, or in this view here. So just keep in mind you have different options about what views or how views display. And you can do them even shaded so that they look more like the part does in our graphic space of our part file. That's helpful if you have an assembly or something, or maybe you want to do it just the isometric view, etc. Okay, so let's go back to our just shown visible edges. That's a good overview on creating our different views. Now we need to get some dimensions into here. And if you're looking up at the toolbar here, you'll see there's one called annotation, and it has a smart dimension tool just like we had in our sketches. So I could click on smart dimension and start clicking in here. Oh, let me get out of my drawing view. Start clicking items, and you can see, so that shows me that that bracket is 5.5 inches wide, and it is 3 inches tall. But when I escape from hitting those dimensions, you'll see they're kind of lightly grayed out. They're not it's dark black. And when I open it, you'll see that it refers to it as a reference dimension. This is RD2. So this is not a part dimension. So that's not what we really want. Sometimes we may need to add dimensions that way, but what we really would rather have are the dimensions we use to create this part. And how we get those is from model items. So smart dimension creates dimensions in this drawing document. Model items brings in the dimensions that were actually used to create the part. So if I click on model items, it brings up this menu over here where I can select all the different information that I want it to import from the part file itself. And so I want it to bring in information from the entire model, and I want it to bring in the dimensions, or what I'm looking at here. So these two boxes here, there I unclicked them, but I'm clicking them back in, and that's everything there. I'm not bringing in anything else right now, just those dimensions. So if I click on that, you can see it brings in all the different dimensions that were used to create the part. And it's not very smart about where it puts them. You can see it puts some on the drawing, which is kind of a no-no as far as drafting standards. So we need to go in and pull ones out that overlap the part itself. And I'm kind of crowded up in this corner, so it looks like I'm going to move this around a little bit to try to make more space for those dimensions. So try to make sure nothing's overlapping. And so this is a case where maybe I would want to use a reference dimension instead of these imported dimensions if I wanted to try to move one of these dimensions to one of the other holes or whatnot here. But that's kind of an overview of how we bring in our dimensions that were used to create the part. And let's talk about why do I want to do that? What's important to use these dimensions that show up as black on our true dimensions? And what's really cool about it is that when I'm using the dimensions that actually are imported from the model, I can edit those dimensions and how they work right here in the drawings. So watch this. Down here, the base flange of this bracket, it looks like I made it 0.62 inches thick. If it turns out I really want that to be 1/2 inch thick, I can put in 0.5 inches. And you'll see they all get kind of a hashed look to them because I've changed something. That means I need to rebuild my part. We haven't talked about that before, but this symbol up here rebuilds. It kind of reruns all of the geometry of the part. And when I do that, you'll see that that flange now is 1/2 inch thick. And if I go back and look at the part file itself, you'll see it's a 1/2 inch thick here as well. So let's do that again, make it a little more obvious. Let's go back. So let's change it instead from 1/2 inch to 1 inch. And rebuild it and see what updates. You see the bottom flange changed in the drawing, and if I go back to the part, we'll see that the part file changed too. So that's why, rather than using reference dimensions, we want to actually import the dimensions from the model. So I'll change that back to my 0.620 and rebuild it. Okay, so again, I want to make sure no dimensions overlap another view and they don't overlap each other. So these ones over here are kind of messy. Let's see if I can pull one of those out so it doesn't quite overlap as much. That looks better. Okay, and one other thing, it put in some smart markings, like it can tell that this is an angle measurement, so put a degree symbol. Here, this radius, that R stands for radius, and then you can see it says 0.250 inches. That's the radius of this fillet right here. It's the same for all these other ones, and if I wanted to make a note to make sure that was clear to somebody, I can I don't even have to double click on the dimension. If I click on the dimension and if I click on it, sorry, I need to rebuild that now. It thought I edited dimension. If I click on the dimension and then hover over that context sensitive box that came up, so I'll do that again, click on it and then hover over this, I can add in extra text. So if I want to put text to the right of it to show that that's a typical dimension, meaning it's the same for all the other fillets in that view, I can do that. I can put right here, I could just type, I accidentally clicked the center, there we go. Just put TYP is a shorthand abbreviation for typical, and you can see it updated that here in the view. Okay, I think that's a basic introduction to creating drawing views, importing dimensions. We talked about the sheet properties for third and first angle projection and scale. Let's take a look at one other thing that we talked about before. If we go to the document properties, this is where we can set things like the dimensioning standards and the units. So again, I had three decimal points of precision on my units. If I didn't want that, if I really wanted 2 decimal points, if I change it here, say OK, and come back, you can see all the dimensions updated to just 2 decimal points. Another thing that I can do there in that same spot under document properties, as a reminder, that's also under units where I would change from whether I want to be in decimals or in fractions. So if I put in fractions, then you can see the decimal goes away. And if we come back, now my dimensions will be in fractional inches. So just a reminder, sometimes students can't remember how do I switch back and forth between units, and that's in your document properties. And again, remember, if you save your drawing, once you have all these units and whatnot set the way you want, if you save your drawing as a drawing template, that will carry that forward, you know, your precision, your units, your dimension style, things like that. So once you have a drawing that you really like all your settings for, I would recommend that you go up to do the file, save as, and save it as a drawing template, just as a reminder. Now that we've got our drawing made, the last thing will be to save it. So we just talked about saving it as a template to use in future drawings, but to save this individual part file, first you would just save the drawing, and it asks you want to save both the part file and the drawing, and I would say sure, this is my drawing that I'll save in the same location as my part file, and you'll see the file type it lists as Solidworks drawing. So I'll save that, but then a lot of times I will ask you to turn your drawings in as PDFs. So to do that, some people will try to go and print them to a PDF printer, but you can just go to File and then Save As and select Adobe Portable Document Format PDF. And you can do that from within SolidWorks without printing to a PDF printer or whatnot. So save it as a PDF. You can do some options in there if you had multiple sheet drawings and whatnot. There's all kinds of different things. For right now, we're doing things very basic, single sheet. You just can use the defaults. So save as PDF, and I usually leave View PDF after saving checked so that it opens my file and I can verify that it turned out how I wanted it to. So you'll need to do that when you're turning in drawings. Most of the time I'll ask you to turn them in as PDFs. Okay, I think that's a enough for today for our introduction to creating two-dimensional drawings from three-dimensional parts in SOLIDWORKS. Thanks for watching, and stay tuned for our next video.